Math 1, Systems 2.1 and 2.2. So, the first ones want us to identify which of the given points are solutions. Okay. The way we do that is we take the x and the y variables and plug them in for the x and y there. So it'd be like 3 times 2 plus 2 times 4. And we're going to see, does that equal 12? If it does, it's a solution. If it doesn't, it's not. Well, 3 times 2 is 6. 2 times 4 is 8. 6 plus 8 is 14. And 14 does not equal 12. So we eliminate that one. Okay. Then we do it for 3 and 2. So change those to be 3 and 2. 3 times 3 is 9. 2 times 2 is 4. 9 plus 4 is 13, which is not equal to 12. So we eliminate that one too. So we do C. 3 times 4, 2 times 0. 3 times 4 is 12. 2 times 0 is 0. This one does work. Now you may want to stop there, but we need to check the last one too. Okay, so 3 times 0 plus 2 times 6, does that equal 12? 3 times 0 is 0, 2 times 6 is 12. So yeah, this one works as well. So C and D are both possible answers on that one. Okay, number 2, same idea here. So I've got 5 times the x value minus just the y value will equal 10. So first one, 5 times 2 is 10, minus 0 would be 10. So A would work. Now let's try B. So 5 times 3 minus 0, that would be 15 minus 0. That one's not going to work, is it? Okay, then we do 5 times 0 minus a negative 10. Minus negative is like plus, so we'd have 0 plus 10, which is going to be 10. So C would also work. And then finally 1 and 1. So 5 times 1 minus 1. That would be 5 minus 1, which would be 4. Does not equal 10. So we would just have A and C on that one. Alright, 3, 4, and 5, they want us to find out what the other term would be. So on 3, I'm given 2 for x, so I'd plug in a 2 for x. I want to find out what y is, so I just leave y there. So I'd subtract 2 and get y equals 4. So my solution would be 2, 4. Now if I'd B is 0, so 0 for x, solving for y, so we'd have y equals 6. Then C, we have y for 0, so we'd have x plus 0 equals 6, so x would equal 6. Okay, so number 4, same idea, 2 times x plus 4 times y equals 8, and we want 2, so 2 times 2 is 4, plus 4y equals 8, subtract 4 from both sides, we have 4y equals 4, divide by 4, so y would equal 1. So we'd have the point 2, 1. Then we do zeros for x's and zeros for y in B and C. So I'd go 2 times 0 plus 4y equals 8. That would become 0, so we'd have 4y equals 8, divide by 4, and y would equal 2. So I'd have 0, 2. And if I did it the other way, it'd be 2x plus 4 times 0 equals 8. So we'd get 2x plus 0 equals 8. So 2x equals 8, divide by 2, x would equal 4. Okay. Then number 5, we do the same thing. So 2 for x, so I'd go 3 times 2 minus y equals 8. 3 times 2 is 6, minus y equals 8. Subtract 6. We have negative y equals 2. Divide by a negative 1, because it's like there's a negative 1 here. We'd get y equals negative 2. So 2, negative 2. Then if we did it for 0 for x, 3 times 0 minus y equals 8. We'd have 0 minus y equals 8. Negative y equals 8. Divide everything by a negative 1, we'd get y equals negative 8. And if we have for 0 for y, we'd have 3x minus 0 equals 8. So 3x would equal 8, divide by 3. We'd have x equals 8/3, which I would just write it as 8/3. But you may want it as 2 2/3, or 2.6666 repeated, or 67, or... Okay, so that's how we do those ones. Alright, now let's take a look at number 6. So a theater wants to take in at least $2,000 for a certain matinee. Children's tickets cost $5 each, and adult tickets cost $10 each. The theater can seat up to 350. Find 5 combinations of children and adult tickets that will make their goal. Okay, so we've got to figure out, okay, so we can have 350 people. Well, let's start out, here's a good place to start. What if they were all adults? So if I did 350 adults and 0 kids, here, let's do it in table format. So we have adults, kids. So let's say we did 350 and 0. Well, adult tickets are $10 each, so times it by 10, you'd have 3,500, which is more than 2,000, so that would work. If we had only adults coming, that would be great. What about kids? What if we did 0 adults and 350 kids? So we'd go 350 times 5, which would be half of this basically, wouldn't it? Okay, is that going to be bigger than 2,000? It's not. It's going to be like 1,750. Okay, so that one wouldn't work. So maybe we could test another one. What about 200 adults and 150 kids? So then you may want to use a calculator to help you with some of these numbers. So 200 adults would be 2,000 right there, wouldn't it? Okay, so that's going to be more because it doesn't matter how many kids we have, they're going to be more. So 200 adults, 150 kids would work. Okay. What about 150 adults and 200 kids? What if we did that one? Because we want to have a full house. Now, we could do adults. We could only do like 250 adults and 0 kids, and that one would work right because that would still be more than 2,000. So I could go 150 times 10, which would be 15,000, plus 200 times 5, which would be 1,000. So we'd make 2,500. So that one would work as well. Okay? So you can kind of see what's going on here for any of those combinations. So I want you to come up with at least one more combination on your own and go, 10 times the adults plus 5 times the number of kids. We want it to be bigger than 2,000. Okay? But both of them added together have to be less than 350 to make it work. All right. 7 and 8. So it says graph each equation below, then determine if the point 33 is a solution. So slope-intercept form, my y-intercept is 2, so let's say this is our x-axis and our y-axis. They don't really give us one, do they? So go up to 2 for my y-intercept. Slope of 1/3, so I go up 1 to the right 3. Like this. Draw my line. So now where's the point 33? 1, 2, 3, 1, 2, 3. It's that point right there. It's on the line. So yes, it is a solution. Okay, I do 8. So we start at 5. My y-intercept. Slope of -3, so we make it -3 over 1. We go down to the right, down 3 to the right 1. Okay, so there's my line right there. Plot the point 33, which is right here. So it's not a solution. Okay? Alright guys, there we go for that one.